Hello everyone, welcome to the 8th video lecture of class 9 science. In this video lecture, we'll be starting with our second lesson, that is motion. In the previous lesson, in this video lecture, we are going to study about motion, types of motion, uniform and non-uniform motion, distance and displacement. Whenever we talk about state of an object, so we know that there will be two states, that is rest and the motion. So I'm not talking about their physical state, that is liquid, solid and gases. I'm not talking about that. When it is motion, we can talk about two states, that is rest state, another one is motion state. So what is this rest? A body is said to be in rest, in state of rest, when its position does not change with respect to a reference point. For example, you are a reference point with respect to you. Reference point means with respect to some object, with respect to some body, we are defining the motion of the other body. Okay, with respect to you, the pen which is lying in front of you, the mobile or the laptop or the computer which is in front of you, if it is not changing its position, then it is called as, or then it is said as, the object or the computer is at rest if it is not changing its position with respect to you. Okay. Then what is this motion? If the same object is changing its position, that means you're taking your pen and keeping from one position to the other position. With respect to you, the position of the object, the pen, has changed, right? So then we say that the pen was in motion. The pen moved. Okay, so the motion is a relative phenomena. What is this relative phenomena? Let us understand this. An object appearing to be in motion to one person can appear to be at rest as viewed by another person. For example, trees on roadside would appear to move backward for a person traveling in a car, while the same tree would appear to be at rest for a person standing on the roadside. This is a common thing. We all know that the trees will be at same place, but whenever you're traveling, you see that the trees are moving backwards, right? That means you feel that the trees are moving. But the same tree will be at rest for the another person who is standing by roadside. Okay, so that's why we say that the motion is a relative phenomena. Okay, this is a small thing to show the movement. Okay, for now, instead of taking you as the reference point, let us take the shop which is given in the picture as the reference point. With respect to the shop, now the delivery boy is at rest, right? Because he is not changing any position with respect to the shop. The shop is also at the same place and the delivery boy is also at the same place. Now what happens? Now he travels from this position to this position. From here to here he has traveled. With respect to whom? Shop. So with respect to this shop, the person has changed, the delivery boy has changed his position from A to, this is, let us call point A, this is B, from A to B. So then we say that the object has moved. Okay, so this is a state of rest and state of motion, and we even studied that the motion is a relative phenomena because an object which is moving for one person can be viewed as the object is at rest for the other person. Okay, am I making some sense? Yeah. Okay. Types of motion. In physics, motion can be classified as below. The first type of a motion is relative motion, motion which is happening along a straight line. If any object is moving on a straight line, then we call such a motion as linear motion. For example, cars traveling on a straight road. Okay, so it's an example for the linear motion. If any object is moving on a straight road or a straight line motion is nothing but the linear motion. Okay, the next kind of a motion is motion along a circular path, the fan rotating. If any rotating phenomena, if we are observing in our day-to-day life, then we call such a motion as, okay, I don't know why the fan is not rotating here, but okay, you know that the rotating motion, we are all aware of it. Okay, if any motion is happening along a circular path, that kind of a motion is called a circular motion. Quite simple as that. And the next one is oscillatory motion, relate repetitive to and fro motion of an object at regular intervals of time. To and fro, that means back and forth. If the object is moving repeatedly at regular intervals of time, then it is called as oscillatory motion. For example, when you are playing in swing, it moves to and fro, right? Front and back. Whenever you're sitting in a swing and playing, it moves front and back with almost regular intervals of time, and it happens repeatedly, right? So this kind of a motion is called as oscillatory motion. So one more type is a random motion, motion of an object which does not fall in any of the above categories. If it is not a linear motion, not a circular motion, or not a oscillatory motion, then it is called as random motion. Okay, these are the different types of motion which we come across in a day-to-day life, especially when we talk about physics of a motion. Okay, so then let us study about a phenomena called uniform motion. So let us consider a situation. Consider a car which covers 60 kilometers in the first hour. So there is a car, okay, consider this as car. It is moving in 1 hour. This is covering 60 kilometer. Okay, it has covered 60 kilometers, this much of distance in 1 hour. The next 1 hour, the same car covers again the 60 kilometer distance. Then again the same car is moving and again it covers 60 kilometer in 1 hour. Okay, so whenever you see there is some uniformity, yes or no? Every 1 hour the car is traveling 60 kilometer. Every 1 hour the car is traveling 60 kilometer. So that means we can say that the motion of the car is uniform. There is some uniformity in which the car is moving, the way in which the car is moving. So this is an example of uniform motion. So it is defined as an object is said to be in uniform motion if it covers equal distances in equal intervals of time, howsoever big or the small these time intervals are. Here we have taken a time interval of 1 hour. Every 1 hour, what happens we saw. If I am going for a smaller time interval, like every 1 second or every 1 minute, what will be the distance traveled? If any object is covering 1 millimeter distance in 1 second, next 1 second again 1 millimeter, next 1 second 1 millimeter. If the motion of an object shows this kind of uniformity, then we call it as a uniform motion. An object is said to be in uniform motion if it covers equal distances in equal intervals of time, and that will be called as uniform motion. Okay, then another one which is opposite is nothing but the non-uniform motion. Okay, the kind of a situation which we are taking here is bit different. Consider a bus starting from one stop. It proceeds slowly when it passes through a crowded area of the road. Suppose it manages to travel merely 100 meter in 5 minutes due to the heavy traffic and is able to travel about 2 kilometer in 5 minutes when the road is clear. Now what is the situation here? Bus is standing. Now the bus is starting from its bus station, okay, or from your school, or for example bus station. Okay, bus station it is starting, and we all know that bus station will be a bit crowded. So what happens, the driver will start the bus and starts to move it with a he'll go very slowly, right? So what happens, in the first 5 minutes he could travel, the bus could travel only 100 meters, but bus could cover only 100 meters. After traveling 100 meter after 5 minutes, so what happens, the crowd will be less, the traffic will be less. So what the bus driver will do, he takes the bus and he drives the bus with more speed. So what happens, bus could cover more distance in the same interval of time. Now what happens, in 5 minutes now the bus is traveling 2 kilometers. The first 5 minutes bus traveled only a smaller distance of 100 meter in 5 minutes. Okay. Next 5 minutes the bus could travel a larger distance of 2 kilometer. The time is same, the time interval is same, okay, but the distance traveled is different. So here the uniformity is lost. It is not uniform. First 5 minutes it traveled only 100 meters. Next 5 minutes it traveled 2 kilometers. Next 5 minutes it may travel some 60 meter. In the next 5 meter it may travel 1 kilometer. So there is no uniformity. It changes. Okay. So this situation is an example of non-uniform motion. Okay. Hence the motion of the bus is non-uniform, that is it travels unequal distances in equal intervals of time. The time interval which we consider was 5 minutes and it was constant, but in the 5 minutes the distance traveled by the object or the bus here is different. So the definition is, an object is said to be in non-uniform motion if it covers unequal distances in equal intervals of time. So it's just opposite of uniform motion, right? If it covers equal distances in equal intervals of time, it is called as uniform motion. If it covers, it here is an object. If an object covers unequal distances in equal intervals of time, then it will be called as non-uniform motion. Okay. So, in the previous lesson, that is physical quantities, whenever we always talked like it is a scalar quantity, something is called as a vector quantity, all those things. So, make it bit clear. So, what is the scalar quantity? It's a physical quantity having only the magnitude. If any physical quantity is given to you and it has got only the magnitude. Magnitude is numerical value, like your height or your mass. Okay, so it has only magnitude, right? So number to it. It will not. I mean, your height is 130 centimeters in upward direction. Will not say that. Okay, so it has got only the magnitude, the numerical value. So then, if any physical quantity is having only the magnitude, then it will be called as scalar quantity. If any quantity which has got both magnitude as well as the direction, then it will be called as a vector quantity. So with this concept already we have discussed in the previous videos, but just to brush up your memory, just I revised it. Scalar quantity has got only magnitude, vector has got both magnitude and direction. So distance and displacement. Motion of an object, of any object, is described in terms of distance, displacement, speed, velocity, acceleration, and time. So these are the different terminologies which we use whenever we discuss or describe the motion of any object. Okay, so for that, to describe any kind of motion, so what we need, all these terminologies. So before using those terminologies, we should know what exactly they are, right? So for that purpose, we are going to study about first two things, that is distance and displacement, in this video. So distance. Okay, so for example, I'm at point A. It's like a gate of your school. Okay, now what happens once you are at the, this is like a, this is you, the point here is you, and you are at the gate now, gate, school gate, and you enter. So what is that all children will do? We will not go straight into a class. He will go like this, like this, like this, and finally we reach our classroom from gate. So the, this gate is called as point A, the classroom is called as gate point B. So never we do it, right? We will not go straight to our class. No, we will never do it. We will go here, 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 playing, kicking the stones and the ball, or whatever it is, which is lying on the ground. We will do that, and finally we reach the classroom. So the path traveled by you from one point, whenever you travel from one point to another point, the total path you cover is called as the distance traveled. Okay, the path traveled, distance covered, or the path covered by any object from moving from one point to another point is called as distance. The total length of the path traveled by the body from one position to another position is called as distance traveled by the body. The actual length of the path traveled by a moving body, irrespective of the direction, whichever the direction you move, we are considering all the path length, the length of the path you have moved when you reach from one point to another point, okay, is called as the distance. It is measured in meters because it's a length, right? It's a kind of a length. SI unit of length is nothing but meter. So it's a scalar quantity having the magnitude only, because whenever you measure the path length of your path taken by you to reach classroom from your gate will just a numerical value. Okay, so this is nothing but distance. So what is this displacement then? The same example, let us take. You have travel, this is your gate, again point A, and the point B, this is your classroom, and this is your, you have moved like this. Okay, so what is this? If you go and calculate the length of this zigzag path, it's nothing but the distance. So displacement is the distance or the length which is very much shorter. The shortest distance which you can take between any two points is nothing but a straight line, right? So this will be, if you want to save your energy, what you will do, you will not go here and there like this, you will just straight away go to your classroom like this. It will be like a straight line. So what happens, you, whenever you take a straight length or straight path to your classroom, you will be following or you will be traveling the shortest length. Yes or no? The shortest length you will be traveling. And this shortest length between any two points or any two positions is nothing but the displacement. The distance is the actual length followed by you, and displacement will be the shortest path. It is defined as the shortest distance between 2 points. Okay, here you have to add shortest distance. Okay, here the shortest distance between 2 points. It's a vector quantity having both magnitude and direction. Why it is a vector quantity? What about the direction of it? We will study in our next class. Okay, for now you should know that it's a vector quantity because it has got both magnitude and direction. Because it is a length, obviously its SI unit will be meter. Okay, so this was about the two different things related to the length, that is distance and displacement. They are distance and displacement. So what is the major difference between this displacement and distance? So the distance is the actual path or the total path traveled by the object when it traveled from one point to another point. The displacement is nothing but the shortest distance between, or the shortest length between two different positions traveled by an object. Okay, so one of them is a scalar quantity, another one is a vector quantity. Since both of their length, their SI unit is meter. Okay, so this is the general introduction to the topic motion. So in this we studied what do you mean by motion, what do you mean by uniform and non-uniform motion, and we even studied that motion is a relative phenomena, and then we studied different types of motion, and then finally we studied two terminologies, that is distance and displacement, and they are how actually they are different in nature. Even though both of them are talking about the lens, how exactly they are different, all these things we have learned in this video.